Question 22 from section B of paper 1 of the 2014 Higher Maths. Now this one's alright as well, really. You should be familiar with this. You did quite a few of these, or you did several of them anyway from the book at the time, and it's been a while since it appeared in an exam. What does it say? Because you've got these two unknown coefficients here, but it gives you two statements, so you're going to get simultaneous equations. It says x plus 1 is a factor. Well, if that's the case, that means that the remainder should equal 0. So why not go through the synthetic division? Maybe you need a slightly longer table because of these unknowns. So that'll be 6, 7, A, and I'll stretch it out a bit, B. And if x plus 1 is a factor, I'll put negative 1 in and see what comes out. So what's the value at negative 1? 6, bring it up, negative 6, bring it down 1, bring it up, negative 1, add it, A minus 1, multiply by negative 1, well that just flips it, 1 minus A. So I've got 1 minus A and add on the B. That's my remainder. So if the remainder is to equal 0, that means that 1 minus A plus B equals 0. Rearrange that slightly. Might be better off saying with that one, instead of negative A plus B equals negative 1, I could have A minus B equals 1 from my first equation. Or you could just keep it in any form you like. The next thing it said was, where are you? 72 is the remainder when divided by x minus 2. So dividing by x minus 2 has remainder 72. So I'll just go through that again. X minus 2 means if I put a 2 through it, then the remainder on dividing by x minus 2 is the same as the value evaluated at 2. So I'll run that through the table. 6, but that's now 12. This is 19, so it's getting big. That's 38. That's 38 plus A. Now I've got to double it again to 76 and 2A. Now I've got to add it up. 76 and 2A plus the B. So if the remainder is 72, it means this lot, 76 plus 2A plus B has to equal 72. I'll just rearrange that to 2A plus B and take the 76 across and subtract it is minus 4. Now they're fine just to add straight away and the B's will disappear. So if I do 1 plus 2, I'll have this. A minus B is 1. 2A plus B is negative 4. Adding them together, I've got 3A, they cancel, and that comes to negative 3. So A equals negative 1. That's a nice enough number for an answer. And as soon as I know what that is, I can go back to whichever one, this one here. So if I substitute A equals negative 1 in 1, I'll have negative 1 minus B is 1. Taking that across, B equals negative 1 minus 1, whichever way you want to do it. So B equals negative 2. So part B properly then, hence factorise the polynomial completely. Now I've rubbed it out to create space, but I could have kept the original synthetic division that had the remainder of 0, because that would have been the one I wanted, and simply substituted negative 1 for A and negative 2 for B in the coefficients of the answer. But I haven't, so I'll just start again here. So this means this is actually 6x cubed plus 7x squared minus x minus 2. And I'll just put this down again. It doesn't take that much longer to do it that way, minus 2, because I still know that minus 1 worked because x plus 1 was a factor. So if I run that through, that will also double check that this works, of course, that those were the correct numbers. That'll be 6, negative 6, 1, negative 1, negative 2, times 1 is negative 1 is positive 2, and that indeed does come to 0. So that I can say that that is x plus 1, and I don't need to justify that because it told me that it was a factor. I don't need to make that statement, or the remainder is 0, so x plus 1 is a factor, times, and what's left is 6x squared plus x minus 2. Then finishing off the factorisation, it's either 6x and x, but then times a 2 is not going to work, so it must be the 3x and the 2x. For a difference of 1, I'm looking for 4s and 3s, so I'll put the 2 there and the 1 there. And then the middle term goes to the greater one, that's the 4, so the opposite sign will go to the outer one. And just a quick double check, 3x times 2x, 6x squared. 2 times negative 1 minus 2 plus 4 minus 3, yep, that works. So there's your final factorisation.